Okay, today we are going to show you the deep learning model evaluation tool. So I already have a data set here, which you have, okay, this is the data set. All right, and this is, I just show you what I have loaded here. This is my segmentation result from my model. So I applied a deep learning, I trained a deep learning model. I applied the model to this dataset. I got a multi-ROI as the segmentation result, which you see here have 6 classes. And this is the frames I exported from the segmentation wizard, meaning it's the training data I used for train my model. So you see I have about 6 frames, and this is the image plane. If you want to double check, this is the image plane, and this is my like one frame here. I set up my keyboard so I can use my key to jump to the next labeled slice. So this is the first one you saw. It's on slice 177. So this is another slice 149. This is one more. Oh, okay. Starting from here, I have 1, 2, 3, 4, 5, 6. I have 6 frames labeled on different slices, and I used this for training my model in Segmentation Wizard. I'm not going to show that again. And after training, I got a model, so I can apply the model to the entire image, the image stack, the volume, so I can have a 3D segmentation. What I'm trying to say today is the evaluation tool. The model evaluation is to evaluate multiple models for the same dataset, which is already have some ground truths, which we just saw the frames we exported. Those are ground truths. So I choose my data. Why I have to? Okay, choose my data. The input for the model is the image data. The output is a bit confusing here. The output is my ground truth, which is this one, from uh, frames from SegWiz. So this is I think it should be renamed, is to make it clearer. It should be renamed like ground truth, because we have an image, we have a ground truth labeling, and we want to evaluate um, the models. Now we see there's no model available. The trick is the slice number here. Slice is when we train a unit model, we have an option for 2D or 2.5D or maybe 3D. So this is the number of the slices there, because I very rarely I use 2D unit, so I have no 2D unit model on my computer now. If I change this to 3, I have one model which uses 3 slices as input. So now I see one model here. If I put 5 here, I see more models even. And some of them are not trained for this dataset. Like this one, the walnut model is trained on this dataset. The other 2 were from other dataset, but because they have the same dimension of input, like 5 slices unit, it could be unit, could be other network, but if it takes the input as 5 slices, the 2.5D with 5 slices, you will see them. And also the output should be the same, has the same number of classes as the ground truth you input here. Because I input here, this is my ground truth, which has 6 classes. So I only see the models with which output is 6 classes. Now I could evaluate my models. For example, I could multi-select two models. Of course, here the first one is trained on the walnut data set. It will have good performance. The other one was not trained on this data set, so it's totally different, and it will absolutely fail on this image. But I'm just for demo purposes, I want to test these two models for this image. So after I selected this, I say, oh, this is the metrics. So you can choose which metric you want to compute. By default is the dice coefficient and the yeah, like the categorical cross entropy. And some others if you want to choose. I just leave this as the default. I do compute. So now the program applies two models one by one or more models by one to this image, but only tested for oh, I'm sorry. I forgot something. I have to cancel now. Because you see a mask here. If you don't choose a mask, it will use the entire image stack, the whole volume, which is not my purpose, it's too big. And I didn't have labeling on most of the regions. I only have labeling. My ground truth is only in this small regions. So I have to provide a mask. To do that, I just generate a new ROI from my frame. From my frames, I use this menu generate new ROI. So you see my frames, the training data is 6-class multi ROI. I converted to a single class ROI. You see the same this ROI has the same regions as the 6 frames, but it has only one class because it's an ROI. So I'm going to use this as my mask. So it has exactly the same size as the frames. Now it should be much faster and more accurate because wait a second. I have to select this again. Compute. So now I apply the model only on those labeled regions. Okay, now you see this model has, for example, the loss function here, the dice coefficient. So let's look at the dice first. This 92%, it's 0.92424. So basically it means the accuracy of the prediction is 92.4%, which is good because it's trained on this data set. For the other model, which is not trained on this data set, it has a very poor dice because it's totally wrong. Okay. Um, I don't see loss in my list. I don't know why. I see loss here. Yeah. Sorry, I don't know why I see loss here, but I have not checked the loss in my list of the metrics. Um, that's so this is the overall evaluation of the model, meaning the 6 classes. Here you see we have 6 classes, and the program calculate only one dice for all classes. So I think it's a mean dice coefficient from all classes, like 6 classes here. And so this is an overall evaluation of the model for all classes. And the next tool I'm going to show you will compute each class for the dice coefficient. So we'll see that very soon. before that, I want to say, you see here, if I want to compare this this model which has 5 slices as input, if I want to compare this model with my other model which has 3 slices as input, because I don't see them the same time in my list, so I'm not able to multi-select them and do compute and see them one to next. Um, I I have to do it twice, so I have to do this first, select this and compute, then I get this back to the 3 slices, and then I do this again. It's okay, we just do it two times and we save, like we write down or export the numbers, but it will be more convenient in the future version of Dragonfly. We will not limit the list to the input, like no matter how many slices the model takes as input, we can see all the models here, all the models with the output of 6 classes for this case. So all the models with output of 6 classes, which match the ground truth here, we will see all the models here. So we are working on that now. So I hope it will be more convenient in the future. And so this is the tool for model evaluation. Before I close this, does anyone have any questions? Okay, if there's no question, we go to the next tool. Next tool is a bit difficult to find, which is here in this list. If you have, for example, if you have one fully segmented ROI, which is from the model inference, and you probably have multiple fully segmented multi ROIs because you may use multiple models. You want compare them, the result, not the model evaluation which we just did for some small regions. You want to compare the whole uh, image segmentation. Or if you want, compare the segmentation result with the ground truth and find out which like what is the dice coefficient for each class. In this case, we should double select the two multi ROIs. So I use my control key, I select both. So you see A and B here, two multi ROIs. Now when you right click them, you have a new menu. So it's segmentation comparator. Um, if you select only one, you don't, and you right click, you don't see this menu. So it's a bit difficult to find. So you have to select both, and then you do segmentation comparator. In this tool, you see ground truth is my exported frames. Subject to compare, I want to compare this is my segmentation result from the model. I may have multiple, so if I have multiple, I can check multiple here. Now the mask is the same. I just want to use a mask for the computing and the metrics. You have all those metrics. I don't remember everything. So if you want to find out how they are defined, you can check our help menu. So you see the name here, true, for example, the false positive, true, for positive, true, negative. Okay. So you have all these options checked. Now we can do compare. And this will give you 6 classes. As we said, this model has output. The first row is the mean. or the overall evaluation. And starting here is the 6 classes. So for each class, you see the dice, and you see the false negative. I don't know. I think it's the number of pixels. I think this is the number of pixels, like 416 pixels has been labeled false negative because we use the ground truth as the truth. So everything is different from the ground truth will be either false negative or false positive. So you see the number of pixels here. Oh, okay. Well, it's well defined. It's a true negative rate. Um, yeah, it's true positive rate. So, okay, I never saw this before. So this is how we evaluate the result of segmentation. Compare them with the ground truth, and we find out for each class what is the metric. All right, so that's all I want to show today. It was quick, and does anyone have any more questions? All right, so if there's no more question, we'll stop now. And thank you again for joining us today. And hope everyone have a good night.